Hello, everyone, and thanks for coming to see this talk. My name is Dario Fagioli. Here in this slide, you can find some information about myself, including some of the stuff that I do within the openSUSE project. If there is anything that is interesting to you that is mentioned here, feel free to reach out to me at these addresses. But now let's jump directly into the subject of the talk, which will be a talk about Linux containers. Now, I think that what Linux containers are is something that we pretty much all know quite well by now. Anyway, I just fished some not so random quotes from the internet about Linux containers, and if one reads them, you will learn that containers are a way to deploy and then run services or applications in such a way that they are isolated from the host and also isolated among each others. And we also can read that it would be a best practice for containers to be immutable. So it shouldn't happen that someone goes and modifies their content in a way that makes them different, that makes them look different from the container image that they are built out of. So with this in mind, let's move to the actual subject of the talk, which is two tools. One is called Toolbox and another one is called Distrobox. And they definitely are tools that have to do with Linux containers because they are tools that let someone help someone building and managing a special kind of Linux container. Why special? Because they can help us build and manage containers that are tightly integrated with the host, so not isolated from the host at all. Containers inside of which typically users run a lot of even very different services or applications, sorry. And containers that, if modified, they keep their state, even if this means that they diverge from the image out of which they were created. So basically, we are violating all the best practices and all the quotes from the previous slide. And why is that? Well, there are, in my opinion at least, reasons. Let's consider some example situations. So let's consider the first example situation, which is you are using an immutable OS. An immutable OS such as, for example, Fedora Silverblue, openSUSE MicroOS, maybe desktop or not, Endless OS, and others. In an operating system where, in general, we can say that the root file system is read-only. And so it's not very handy, if possible at all, to install, for example, additional applications, which on the other hand is something that someone might want to do on an operating system for actually being able to use it. And this is one first example. Another first example is when you do development work and you deal with applications that you have to build from sources which have a lot of dependencies. And without going too much into details, the problem could be, for example, that you install all these development packages every time that you want to build from source the application you're working on, QEMU in this example, and then you probably, at least I do, forget to get rid of them when you don't need any longer. Or maybe it's even worse, maybe of some specific one or more than one of these development libraries, you need a specific version, and so you have to install it manually. And this is not nice, not something nice to do on the main operating system you are also using for actual work. And there are even more complicated cases. And this was the second example I wanted to quickly mention. The third one is, uh, for example, let's consider how openSUSE Tumbleweed works. openSUSE Tumbleweed is our reliable rolling distribution from the openSUSE project, which I think we can say it's reliable because we test all the snapshots with OpenQA before releasing them. However, what I think often happens is that users have to or decide to add the third-party repositories, such as Pacman for codecs or some other specific official or less official ones because they want or because they need them. The result being that what the user are using is not what we have tested. And so it means that having added these third-party repository and having installed packages from there could have introduced bugs or could cause breakages in the system that we weren't able to catch with testing. That wouldn't happen if this third party, the software coming from the third party repository wouldn't be installed on the main operating system, because at that point the main operating system would just be identical to what we test. Okay, still in the same category of keeping it clean, let's consider a troubleshooting situation. So you're working, at some point there is a network glitch, network doesn't work any longer. Typically, what I think most of us will do is start to try to understand and figure out where the problem is, and perhaps start installing, if you're not there already, debugging tools, debugging and troubleshooting tools, perhaps even change configuration files and stuff like that. Then at some point the issue is fixed, either by itself or because of our actions, whatever. Most likely, a lot of the stuff that we have done, installing new packages or the modifications that we have done on the system, should be rolled back. But again, that's probably something that does not happen all the time. And it's in theory, potentially dangerous. Imagine a situation where this happens repeatedly, even over a long time span. At some point, you don't know any longer what the status of the system is. So how about there is a way of installing applications if you are in an immutable OS, doing your development, installing third-party packages and applications, and doing troubleshooting somewhere else, so somewhere that is not on the main operating system. That would be quite interesting and quite useful in these cases, because it would help prevent all the potential issues and problems that each of these situations that we have seen quickly, maybe too quickly, sorry for that, can cause. Now, what does it mean outside? Outside where? Okay, spoiler, I'm going to say and to suggest that we can do that in a container. However, it has to be a special container, because we said that we want to be able to install to install applications inside of that container. So it has to keep its state, in the sense that it has to keep this application installed when we need them, when we enter the container because we need them. It has to be a container inside of which you can run our workload, so it has to have not only the tool that we need for it installed, but also all our files accessible from inside of it. And it has to be a container from which we are even able to perform something like troubleshooting actions for the host, but still being inside the container, because we want, for example, to install the troubleshooting and debugging software inside of the container, but then debug a networking issue which is happening on the host, of course. So what's the technology that what can we use? What's the technology that allows us to do so? We can use a privileged Podman or even Docker container, which is tightly integrated with the host, which is exactly what we said at the beginning of the presentation. Of course, we will lose everything which is related to security, because the container is tightly integrated with the host. It's a privileged one, but that's fine. That's not a goal for this talk, and it's not a goal for this particular container and containers that we are talking about. So Toolbox. Toolbox is a project hosted here. The source code is here at this URL, which is basically a shell script that acts as a wrapper for helping us to create and use and manage exactly the kind of container that I just described. So it's born with the troubleshooting use case in mind, but then it evolved and is useful for other purposes as well these days. Anyway, if you are on openSUSE Tumbleweed and you want to use Toolbox, you just install it with Zipper because it's in factory. If you are, for example, on macOS, either desktop or not, you find it pre-installed. Let's see it in action very quickly. So we want, for example, to create a container and to enter inside of this container for doing maybe some of the things that I mentioned before, doing our daily job as developer or doing some troubleshooting or whatever. Okay, this is how we do it. So Toolbox, it's name of the tool, it's also name of the command. Then enter, like enter where, enter in the container, and then the name of the container, which I totally made up for this example. Note that the name of the container also kind of becomes the host name of the machine while we are inside of the container, while instead this is the host name of the actual host. Toolbox the Toolbox command takes some parameters, which I'm not describing here in details. It also can read a configuration file, which can be this one, but also other ones. And it pulls down an image out of which it creates the container that we want, that we are asking it to create, and inside of which we want to enter. By default, if you are on openSUSE, it pulls this special toolbox image. It's an image which is very similar to our Tumbleweed image, but with some small differences. Now, I said creating, using, like entering inside, as we have just seen, but also managing these containers. So how does Toolbox help us do that? Well, yeah, create, I mentioned, enter, it was in the previous slide. We can use Toolbox run to run a command directly from inside the container without even entering it. But then that's pretty much it. If we want, for example, to list the containers or to remove some of them, there is no Toolbox specific command for these activities yet. And we have to use Podman directly, which of course it's suboptimal because it lists or allow us to remove all the containers that we have on the system that Podman manages, not only the one that Toolbox created, but this is the current situation. The concept of rootful toolboxes is interesting, and we will expand on it later. Just for now, let me quickly mention that it's possible to create or even directly enter a container adding the -r parameter to the Toolbox command line, which means that the container itself will not run as your default user, so that would be Dario, my user in this example, but it will run as root. And we will see what this means later. Now, Distrobox. Distrobox is something very similar to Toolbox, to what I just described and called Toolbox. It's also a shell script. It also wraps Podman or Docker for creating this special kind of tightly integrated with the host container and so on and so forth. It's actually born to enhance the Toolbox interface and user experience. And it managed to, in my opinion, do that by quite a bit. For example, one of the most interesting aspects is that you can really use arbitrary images for that, but we will see more details about this in the remainder of the presentation. If you are on openSUSE Tumbleweed, Distrobox is in factory as well, so you can just install it with zipper. And even if you are on macOS, of course, you can install it from factory, of course, using the appropriate tool, not zipper, but for example, transactional update pkg install. With Distrobox, when using Distrobox, you have to create the container first, like this. The syntax is very simple: Distrobox create and then the name of the container. Distrobox as well can all Distrobox commands as well take a number of command line parameters. I'm not going into all the details here. Just let me say that by default, if you are on openSUSE, on an openSUSE distribution, by default, the image that is pulled for building the container on top of it is our official Tumbleweed image. This can be changed on the command line or also modifying, writing the appropriate entries in the Distrobox config file, which is one of these. Okay, after you have created the container, you can enter inside of it, which happens with Distrobox enter and then the name of the container. The output is this nice status report of the various stages and steps necessary for initializing the container and actually entering inside of it. Be aware just of the fact that this will take quite some time the first time that you do it for each container. So for a newly created container, the first time that you enter inside of it, it's going to take a while, but it's only that one first time. After that, it's going to be really fast. Toolbox didn't, but Distrobox has a dedicated management interface for its containers, so it's possible to do Distrobox list, Distrobox stop, Distrobox rm, sorry, and these are all commands that will affect only the containers that Distrobox created and not all the containers that you have on the system managed by Podman or Docker or whatever. And for each of these subcommands, there is, of course, an inline help, which can be printed on the console with --help. Distrobox as well as the concept of rootful containers. And similarly to Toolbox, you can create, enter, list, stop, remove a rootful container, so a container that runs as root on the host, by just using the Distrobox commands and adding the --root option. Okay, now something that I've mentioned multiple times is that Distrobox and Toolbox containers, like all other Linux containers, are built out of images. And I said that on openSUSE, the default image that is used is it's the Toolbox image for Toolbox and the Tumbleweed image for Distrobox. However, I also said that it's possible to change this image and to tell Distrobox or Toolbox to use a different base image for your containers. And so, for example, we can use a Tumbleweed image if we are on Tumbleweed or macOS, but we can also use a Tumbleweed image if we are on Leap, or a Leap image if we are on Tumbleweed, or even, in theory, try and build containers out of images of different distributions, like Fedora if we are on Leap, or Arch if we are on macOS, or Ubuntu, Debian, wherever we are uh, as an host. Now, how well does this work with either tool? So for Toolbox, it kind of works, but these, and I mean, especially using images which are not openSUSE images, this has never been the goal of the project, so and probably never be, at least to achieve full compatibility. So I think I could say that as soon as the image has sudo pre-installed, things should work. And it's also the case that some of the images for the images for some of the main distributions, we also try to fix them up and make it work in Toolbox, in the tool, in the script. But we don't go out at great length toward that goal. So if you are using non-standard images with Toolbox, there might be probably trivial, but still annoying issues that you will have to solve. On the other hand, for Distrobox, it actually was one of the main goal of the project. And with Distrobox, it is indeed the case that you can use lots and lots and lots of different images of a lot of existing distros as a base of your containers, no matter where you are as an host. And the upstream project run automated tests and optimize the script to work well with all the various images, so that to achieve the goal, the result that as many distributions, as many images from different distributions work well with Distrobox. Then we can say that it's another use case for these tools and for Distrobox in particular, because this means that yes, you are on, let's say openSUSE Tumbleweed or openSUSE macOS desktop as an host, but if there is an application that only runs in some other distro, and this distro is as an image which is supported by Distrobox, then you can run that application as well by just creating a Distrobox container out of that image. Or maybe you can use you can use Distrobox and the image of a more updated distribution if you are stuck, or if you like to stay on a more old, or should I say stable distribution for the main and base OS. Or if you want to do, or it could be very handy if you want to do development or maybe packaging for any, or for whatever distribution, for a distribution for which you have an image, no matter which one is your actual host OS. It is also possible to point both Toolbox and Distrobox to images, to custom images, so images that you are making yourself because you want something specific or special to be already there inside of your containers. And for Toolbox, this is I don't know if I should say recommended, but it's probably the best way of overcome some of the rough edges that the tool has, for example, when running graphical applications, and we will see about this later. In Distrobox, if you're using Distrobox, is of course also possible. However, it's also possible to let's say customize the image, although it's not technically correct. So the image can still be the out of the box and the default one of the distribution that you want to use as a base of your container. and you can use, and I defer you to the official documentation for the details on how to do that. You can use these special command line options for example, adding packages to, or doing some even some more advanced configuration on the image itself, on the default image during the container creation and initialization. Sorry. So what about rootful, rootless, whatever containers? I mentioned these terms and I promised that I would explain them better. Okay. As you may know already, Podman supports rootless mode. So you can start a container as a user, and then inside of that container, you can have your user configured inside of it, which is exactly what Toolbox and Distrobox are doing. And you can even become root, for example, with sudo inside of the container. But if the container has been started as a user, started by your user, you will not be able, for example, to modify or even read, depends on the permissions, things that on the host are owned by the root user. That's the meaning of rootless in Podman. On the other hand, if the container runs as root on the host, and specifically if a Toolbox or Distrobox container run as root on the host, which means that you started with, you entered inside of it, you with the Toolbox enter -share or with Distrobox enter --root, then this means that if you become root inside of the container with just sudo su, then you have basically the same powers that you have when you are root on the host. And considering that, as we said, large parts, pretty much everything of the host is reachable, is exposed inside of these special containers. Well, be careful when you do that. At which point one can think, well, let's just not do that and just use rootless containers. It's safer. Security is not a goal. We said it already, but at least it's safest. I don't risk messing up my host. Well, yes, all the time that that it's possible, I think you should do it, and I try to do it as much as I can myself. However, there are things that you cannot do from a rootless container. Just as before, quick examples. We mentioned troubleshooting, and if you have to use nmap inside of a container for troubleshooting a networking issue on the host, then for the command to work well, you have to be root on the host. So you have to be in a rootful container, and you have to become root inside the rootful container, and at which point you are able to use it. For troubleshooting, having rootful containers available is a quite interesting and important thing. Of course, it comes at a price in terms of risks, but if used with care, it's very powerful. A bit less expected, but it is what it is. For example, if you do RPM package build with OSC, currently, for reasons that are too long to explain, that also doesn't work in rootless containers either. And so if you want to do that, you need to do it in a, you want to do that in a Distrobox or rootful or Toolbox, sorry, container, you have to do that in a rootful one. As I said, it has to be possible, and it is possible, to run graphical applications, to install and also to run graphical applications inside of Toolbox and Distrobox containers as well. And the containers are already configured to be able to see the display, connect to the bus, everything that it's necessary. So you just install the applications and run them. If you do that in Toolbox, just out of the box without taking into account the fact that the image that you use for Toolbox is a little bit special, then you will have not perfect results and you have to figure out how to fix it. Distrobox, which is much more focused in um, toward this kind of use case, everything will just work out of the box. Or even apps that need the 3D rendering. You just have to install the NVIDIA KMP if you have an NVIDIA card like I have on this box, and I like it. And I like it as an example because it's weird that you have to install the NVIDIA drivers and also KMP inside of the container. But as soon as you do that, even graphical applications that needs 3D rendering work inside of the container, and you see them displayed in your graphical sessions like they were running on the actual host. Other nice examples of integration between the host and these containers is when you, for example, in GNOME Terminal can configure the terminal tabs in such a way that they start terminal inside of a Distrobox or a Toolbox containers automatically when you open it. Perhaps you can choose specific shortcuts for it and stuff like that. And another example that I'm mentioning because I use it daily and I like it very much is that, for example, from inside GNOME Builder, you can choose as application runtime, so the place where the embedded terminals are opened inside where the project is built and stuff like that. And you can specify, you can list and pick as a runtime one of the Toolbox containers that you have in your system, and even a Distrobox container or whatever container you have around by listing all the Podman containers. Some more Distrobox goodies. One is, for example, the fact that with Distrobox you can create systemd enabled, let's say, containers, so containers that have systemd running inside of them, which means that you can start services and daemons inside of these containers using the traditional systemctl interface. This is not possible out of the box with Toolbox. It's possible that you would have to modify Toolbox itself. Instead, with Distrobox, it's just possible by using the --init parameter. You can export apps, so we have already seen that you can install applications inside of the container. With Distrobox, you can while you are inside of the container, you can configure the system in such a way that apps installed there become visible on the launchers of the host operating system of the main OS, and so you can launch them from GNOME shell, even if there is Virt Manager in this case is not even installed on the host. It's also possible, still without leaving the container, to run commands and programs that are in fact installed on the host. So, for example, there is no Podman inside of this twtest Distrobox container, but with this special wrapper, I can reach out and execute Podman on the host, or Flatpak for what matters. So, in summary, I personally think that Toolbox and Distrobox are two tools that are quite interesting and that it could be worthwhile giving it a try. If you are using an immutable OS, you probably are using at least one of them already. and you probably knew about either both of them or at least about one of them already. But even if you are not using an immutable OS and maybe you are not even planning to try to switch to one, I think there could be reasons to give them a look and see if they might help you in streamline your workload or keeping your host OS cleaner or whatever. This concludes my presentation. And if there are any questions, I will be happy to answer them. Thank you again for attending. And yeah,